FET as an amplifier we will learn, under which there are two types, DC analysis and AC analysis. This is N-channel enhancement mode Mosfet. As I told you, it is called enhancement mode because plus VGG is connected to gate. Gate is positive material or P material. Just like BJT, bipolar junction transistor, in which common emitter amplifier was a circuit. Remember that circuit, bring it in front of your eyes, that circuit. CC, common collector capacitor CC1 is connected across gate. VGG is connected through resistor RG. R signal SIG is connected, and VS is also connected at the input side. Then VDD is connected to gate through RD. CC2 is a coupling capacitor of output V0, and RL is a load resistor. This is a circuit of transistor Mosfet as an amplifier. Okay. Now to analyze its DC characteristics, what I have to do? I have to minimize or reduce all AC circuits. AC circuit should be made, AC signal should be made 0. That's why Vs will become 0. So equivalent circuit of this DC analysis is given in following figure. The figure 2 shows DC analysis circuit in which Vs is made 0. That means Vs is open circuited, it is kept out. That's why at the input side gate becomes RG and VGG. Then DC signal VDD is connected and it is like this. So this is DC equivalent circuit. If I connect all AC circuits to 0, capacitors become effectless in a DC equivalent circuit because reactance XC is very high if capacitor frequency is 0. That is Xc is equal to 1 upon 2 pi Fc, F is equal to 0, frequency is equal to 0 for a DC signal. That's why F is equal to 0, that means Xc is equal to infinity. Infinity means capacitor acts as an open circuit. So previous circuit becomes nullifies. Vs, which is analog signal, it nullifies. So equivalent circuit CC2 also has a reactance infinity due to low frequency, that is DC signal, and hence output circuit also becomes isolate from the circuit, equivalent circuit. Now what remains in the DC analysis? VDD, RD, N-channel Mosfet, RG and VGG. All this, and its equivalent circuit is given over here. It is just like you are calculating your DC load line in BJT. You might have studied DC load line calculation in BJT. Same way we will calculate in MOSFETs. Okay. Now RG, VGG is there, VGS is there, VDS is also there, RD is also there, VDD is also there. If you properly look at this figure, you will find that this is DC equivalent circuit. Now I will give you 1 minute to just only look at this DC equivalent circuitry and AC original MOSFET as amplifier circuitry. I will give you 1 minute for each circuit. Just look at it. Look at original circuit. If you want, within this 1 minute you can draw your circuit. You can draw that if you want. I am giving you 1 minute. it is important to analyze DC circuit through a DC load line. DC load line means what? What will be maximum current and maximum voltage that can flow through the MOSFET. That is called DC load line. म्हणजे maximum limit काय लिमिट लोड लाईन म्हणजे मॅक्सिमम लिमिट की करंट तुम्ही इन्फिनिटी वाढवू नाही शकत. यू कॅनॉट इन्क्रीज बियॉन्ड सर्टन लिमिट्स. We cannot apply infinity input voltage to the transistor. What will happen? Transistor will burn. So maximum current carrying capacity of that MOSFET or BJT is called maximum current capacity, and the load line by which voltage and current matches to each other is called DC load line. Maximum current carrying capacity and voltage carrying capacity. Now in a figure you just see what characteristics we are drawing. We are drawing ID versus VDS characteristics. VDS is what? VDS is nothing but output voltage. VDS is it voltage across drain to source. Then what is maximum VDS? That I want to know. Okay, maximum how much VDS I can apply to drain to source, that is called maximum voltage. So that line I will, that point I will mark on a figure, on a graph. What is ID? ID is a maximum current that is flowing through drain and source, and that's why that current, maximum current, is called as ID. So ID, how much maximum current should flow through the MOSFET, that I have to mark, and line passing through ID and VDS is called DC load line. Now how to find out this DC load line? DC load line is useful to understand how much maximum voltage and currents we can apply across MOSFET. Okay, this is advantage of DC load line. Now how to find out? You know Kirchhoff's voltage law. We will apply Kirchhoff's voltage law across output side. So applying Kirchhoff's voltage law across output is across drain to source. Output side is what? VDD, RD, drain, VGS and ground. Ground to ground. It completes one loop at output side. That is called output loop. Okay. So apply Kirchhoff's voltage law at output loop. What Kirchhoff voltage law says? Voltage additions in a loop is equal to 0. That is what a Kirchhoff's voltage law says. Now voltage addition in a loop is equal to 0, and Kirchhoff's current law, what it says? No current coming to the node is equal to current going out of the node. That is KCL, Kirchhoff's current law. And Kirchhoff's voltage law is called a voltage in a circuit in a complete loop is equal to 0. Here we are applying Kirchhoff's voltage law. Voltage law, for this we need a complete loop. In a circuit you will find that there are grounds. VDD is connected to ground, even source of the MOSFET is connected to ground. That means ground to ground connection is there, and at the output side you will find a complete loop. When complete loop is there, then current direction is from bottom to upward direction is there. Current is flowing from plus to minus. That's why there are three voltages available in the loop. Which are these three voltages? VDD is there and VDS is also there. VDS means drain to source voltage. VDD means supply voltage. And another voltage drop has been developed across RD, that is called ID into RD. So these three voltages are there. If I add these three voltages, there will be these three voltages will become 0. So if I apply Kirchhoff's voltage law across this output side, I am getting equation like equation as given above. VDD, that is VDD plus is there, minus IDRD minus VDS is equal to 0. So go from ID is equal to IS. Go from IDS. I am traveling from source ground. Source is negative, VDS minus VDS is mentioned here. So minus VDS is there. ID and RD, current direction is arrow is reverse direction. That's why minus ID into RD is there. And again if I come to VDD, I am getting plus sign over there. That's why coming to plus VDD is equal to 0. I am coming towards ground. So this is equation which will show me, which will give me 2 points. To find out 2 points, what I have to do? First of all, I have to make VDS is equal to 0. If VDS is equal to 0, then VDD is equal to IDRD. So ID is equal to VDD upon RD. Y is equal to MX plus C format मध्ये equation असेल. ID is equal to minus 1 upon RD into VDS plus VDD upon RD. Now I have made VDS is equal to 0. So ID maximum current flowing through this is VDD upon RD. And when I make ID is equal to 0, VDD is equal to VDS. So VDD, if I make VDD is equal to VDS, ID current flowing through the circuit is 0, and when current is maximum, that is ID is maximum, that time VDS is equal to 0. And if I draw a line across this, ID is equal to minus 1 upon RD into VDS plus VDD upon RD. Y is equal to MX plus C type of line is there, and that line is a reverse resistance type of line. That means it is not increasing, it is decreasing slope type, because minus 1 upon RD is there. So slope of line is minus 1 upon RD. If I compare it with my MX plus C, slope is equal to minus 1 upon RD, and C is plus VDD upon RD. Minus 1 upon RD is slope, which is negative slope. Minus is there, that's why we are calling it as negative slope. So line is going down, or negative line. Okay. So this is a DC load line. This is called DC load line. Now how to find out Q point, quiescent point, a stable point at which there will be operating point. This Q point, that means if I plot a graph when VGG is equal to 2 volt, then working of Mosfet will follow a curve that is having a saturation region, as well as it is having a linear or ohmic region and cutoff region. These 3 regions. VGG is changing this is a characteristics line of Mosfet. Mosfet characteristics line, output ID versus VDS I have drawn, and when VGG is connected to say 2 volt, then characteristics line will follow the path that we have studied in the last lecture also. Getting it?
स्क्रीन ऑफ आहे का?
हां, काय
स्क्रीन स्टॉप केले का?
काय स्टॉप केलंय? हॅलो, स्क्रीन शेअर होत नाही का? दिसत नाही तुम्हाला?
स्टॉप आहे डीसी इक्विव्हॅलंट सर्किट वरती.
इक्विव्हॅलंट सर्किट दिसतंय का?
हां,
डीसी इक्विव्हॅलंट सर्किट दिसतंय का?
हो,
दिसतंय ना? मग त्याच्या खाली एक कॅरेक्टरिस्टिक्स लाईन आहे, तीच आहे, स्टॉप नाही केलेले मी. त्याच्या खालीच आहे ती
नाही
डीसी लोड.
दिसत.
आय एम टॉकिंग अबाउट डीसी लोड लाईन. तिची खालची फिगर आहे ना, क्यू पॉईंट दिसते, दिसते का नाही दिसत? त्याच्या खालची फिगर दिसते.
सर्किट नाही, फक्त सर्किट दिसतंय.
फक्त सर्किट दिसते का? ओके ओके ओके. मग ते लेट मी
सर झूम झाली आहे स्क्रीन.
हां झूम झाली का? ओके, आय विल चेक इट. Now, can you see? Can you see DC load line?
नो सर.
नो सर.
No. Now I reshared it. Now, ID, आता तेच इक्वेशन, I will rearrange that equation. VDD minus ID into RD minus VDS is equal to 0. ID RD is equal to minus VDS plus VDD. ID is equal to minus 1 upon RD into VDS plus VDD upon RD. It is equivalent to Y is equal to MX plus C. As M is slope of this line, it is minus 1 upon RD. If slope is minus, line is decreasing. If slope is plus, line is increasing. That you know, rule, right? Mathematical rule. And that's why slope is minus 1 upon RD and C is constant, which is equal to VDD upon RD. So line is, if I plot this line, ID is equal to minus 1 upon RD into VDS plus VDD upon RD on graph, it will like following graph. That will be following graph, right? So that is called DC load line. That line drawing, I am drawing that line is called DC load line. Got it? That line is having slope minus 1 upon RD, and there are 2 points when VDS is equal to 0, ID is equal to VDD upon RD, and second condition, when ID is equal to 0, then VDS is equal to VDD from the equation. And that line is, we are drawing a line in the negative direction. That is what a DC load line is. Got it? Can you see a DC load line graph?
येस सर.
हां, आता जो काय आहे त्याचा आधीचे कॅरेक्टरिस्टिक्स लाईन तर ऑलरेडी आहेच आपल्याकडे, राईट? ओनली आय हॅव ड्रॉन ए DC लोड लाईन. DC लोड लाईन म्हणजे ऑपरेटिंग पॉईंट जो आहे, विच इज कॉल्ड क्यू पॉईंट, दॅट आय हॅव ड्रॉन. ऑपरेटिंग कुठल्या पॉईंटला ते ऑपरेट होतं. ऑलरेडी कॅरेक्टरिस्टिक सर्किट जे आहे, डायोड ॲज ए ॲम्प्लिफायर, ज्या वेळेला सर्किट असेल, डायोडचं जे कॅरेक्टरिस्टिक्स आहे, आउटपुट कॅरेक्टरिस्टिक्स म्हणजे इनपुट व्हेरी केलं की आउटपुट कसं दिसेल, बाय चेंजिंग इनपुट हाऊ आउटपुट विल बी. BJT, फॉर BJT ऑल्सो by changing input how output will be, and for FET also input is changed, corresponding output will change. VDS चेंज केला, VDD चेंज केला, थोडं व्होल्टेज 1 व्होल्ट वाढवला, 1 व्होल्ट केला, 2 व्होल्ट केला, 3 व्होल्ट केला, corresponding current ID changes to 1 volt, 2 volt, 1 ampere, 2 ampere, 3 ampere and so on. So ID versus VDS graph already we have studied in the previous characteristics. कालच आपण 1 तास त्याच्यावरती दिला आहे की आय डीची कॅरेक्टरिस्टिक्स कशी असते. ओके, ती जी लाईन आहेत त्या 4-5 लाईन असतात त्याच्यामध्ये, दॅट इज कॉल्ड ए कॅरेक्टरिस्टिक्स लाईन. अँड व्हॉट एवर आय हॅव ड्रॉन राईट नाव is a DC load line. Why we are calling it as DC load line? Because from the amplifier circuit we have reduced or removed all AC circuits. AC चे समजा कॅपॅसिटर असेल किंवा AC मधला AC व्होल्टेज सोर्स असेल, दॅट आय हॅव रेड्युस्ड, म्हणून ती DC लाईन लोड लाईन झाली. अँड दॅट DC लोड लाईन क्रॉसेस टू द कॅरेक्टरिस्टिक्स लाईन ॲट सर्टन पॉईंट. म्हणजे ह्या 2 लाईन जिथे क्रॉस होतात, that point is called Q point of the circuitry, अँड क्यू पॉईंट इज व्हेरी व्हेरी इम्पॉर्टंट. हा नॉर्मली सेंटरला पॉईंट असायला लागतो. क्यू पॉईंट शुड बी केप्ट ॲट दी सेंटर, म्हणजे त्याच्यावरती ॲम्प्लिफिकेशन होईल. आणि ए सी इनपुट जरी अप्लाय केलं तर त्या आय डीच्या वरती करंट मॅक्सिमम जात नसतो आणि व्ही डी एसच्या वरती व्होल्टेज जात नसतं. त्याच्यावरती जर व्ही डी एसच्या वरती जर अप्लाय केलं तर इट विल बर्न दी सर्किट. आय डीच्या वरती करंट फ्लो झाला तर दॅट इज नथिंग बट ए सर्किट बर्न. ओके, सो दिस इज वॉट ए डी सी लोड लाईन इज. Look at this circuitry again and you can ask me a queries. If there is any queries you can ask me. काही क्वेरीज आहेत का बघा. डी सी लोड लाईनमध्ये लोड लाईन अशीच का आली वगैरे तेच. म्हणजे आता ॲक्च्युली इफ आय वुड हॅव ए ॲक्च्युअल ब्लॅकबोर्ड I would have explained it in a proper manner. I would have given you some assignments to solve. I would have given you a problem to solve so that you will understand properly how the DC load line is running in the reverse direction or negative direction. काही प्रॉब्लेम आहे का बघा त्या just look, take a 1 minute by looking at to look at this DC load line characteristics. त्याच्यामध्ये तुम्हाला क्वेरी असू शकते, विचारा. यू कॅन आस्क मी एनी क्वेरी.